Chapter 13. Simple linear regression. Although some business situations involve only one variable, others require decision makers to consider the relationship between two or more variables. In analyzing the relationship between two variables, there are two basic models that we can use. The regression model covered in this chapter is referred to as simple linear regression. This relationship between x and y assumes that the x variable takes unknown values specifically selected from all the possible values for x. The y variable is a random variable observed at the different levels of x. Testing that a linear relationship exists between the dependent and independent variables is performed using the standard statistical procedures of hypothesis testing and confidence intervals. A second model is referred to as the correlation model and is used in applications in which both the x and y variables are considered to be random variables. These two models arise in practice by the way in which the data are obtained. Regression analysis and correlation analysis are two of the most often applied statistical tools for business decision making. Scatter plots and correlation. Decision-making situations that call for understanding the relationship between two quantitative variables are aided by the use of scatter plots, or scatter diagrams. A scatter plot is a two-dimensional plot showing the values for the joint occurrence of two quantitative variables. The scatter plot may be used to graphically represent the relationship between two variables. A numerical quantity that measures the strength of the linear relationship between two variables is labeled the correlation coefficient. The sample correlation coefficient, R, can range from a perfect positive correlation, plus 1.0, to a perfect negative correlation, 1.0. A test based upon the t-distribution can determine whether the population correlation coefficient is significantly different from 0 and, therefore, whether a linear relationship exists between the dependent and independent variable. Simple linear regression analysis. The statistical technique we use to analyze the relationship between the dependent variable and the independent variable is known as regression analysis. When the relationship between the dependent variable and the independent variable is linear, the technique is referred as simple linear regression. The population regression model is determined by three values known as the population regression coefficients: 1. The y-intercept, 2. The slope of the regression line, and 3. The random error term. The criterion used to determine the best estimate of the population regression line is known as the least squares criterion. It chooses values for the y-intercept and slope that will produce the smallest possible sum of squared prediction errors. Testing that the population slope coefficient is equal to 0 provides a method to determine if there is no linear relationship between the dependent and independent variables. The test for the simple linear regression is equivalent to the test that the correlation coefficient is significant. A less involved procedure that indicates the goodness of fit of the regression equation to the data is known as the coefficient of determination. Simple linear regression, which is introduced in this chapter, is one of the most often applied statistical tools by business decision makers for analyzing the relationship between two variables. Uses for regression analysis. Regression analysis is a statistical tool that is used for two main purposes: description and prediction. Description is accomplished by describing the plausible values the population slope coefficient may attain. To provide this, a confidence interval estimator of the population slope is employed. There are many other situations in which the prime purpose of regression analysis is description. Market researchers also use regression analysis, among other techniques, in an effort to describe the factors that influence the demand for their products. The analyst may wish to provide a confidence interval for the expected value of a dependent variable, given a specific level of the independent variable. This is obtained by the use of a confidence interval for the average y, given x. Another confidence interval is available in the case that the analyst wishes to predict a particular y for a given x. This interval estimator is called a prediction interval. Any procedure in statistics is valid only if the assumptions it is built upon are valid. This is particularly true in regression analysis. Therefore, before using a regression model for description or prediction, you should check to see if the assumptions associated with linear regression analysis are valid. Residual analysis is the procedure that is used for that purpose. Conclusion. Correlation and regression analysis are two of the most frequently used statistical techniques by business decision makers. This chapter has introduced the basics of these two topics. The discussion of regression analysis has been limited to situations in which you have one dependent variable and one independent variable. Chapter 15 will extend the discussion of regression analysis by showing how two or more independent variables are included in the analysis. The focus of that chapter will be on building a model for explaining the variation in the dependent variable. However, the basic concepts presented in this